This example illustrates an advanced debugging feature of Chrona's Validator, where the user can step through the execution of the application code forwards and backwards while operating in closed loop with the plant model. In this example, the plant is a vehicle model simulated by MATLAB Simulink with a variable step solver. The application software consists of a set of controllers for engine, gear shift, and cruise to be executed on an OLSEC real-time operating system. The software, OS, and a visual platform model are executed by the validator. The closed-loop control system is shown in this Simulink model, where the vehicle subsystem block is connected to an S function block which performs synchronization with the validator. We switch now to the application code, which is included in an Eclipse project. Our objective is to walk through the execution of a code fragment of the idle speed controller and observe changes in certain application variables. To this end, a conditional breakpoint was set up in the idle speed controller to pause the execution at this line of code when the execution time is greater than the value shown here. We switch to the Eclipse debugging perspective that has been set up to show the values of two variables: simulation time, which is updated by the validator simulation engine, and test shared, which is updated only by application code. Upon starting the debugging session, the validator performs initialization of the virtual platform model, and then waits for Simulink model to start simulation. We start the simulation from Simulink. Then we switch back to the debugging interface, where we can see that the breakpoint has been reached. Notice the values of the two variables here. We can now step through the execution of the C code line by line. To be able to step backwards, we turn on the reverse debugging feature of the GDB debugger. Then we move forward, stepping over function calls and watching the values of the two variables. Notice that the application code is instrumented with calls to the validator functions set execution time and callback. Nothing changes until here. Now observe that simulation time has advanced, which is expected, but the value of test shared has changed to -1, which is unexpected, since this variable is modified only by application code. We need to find where and when this change took place. So we move backwards into the execution of the code by reverse stepping into the callback function and reverse stepping over validator interface code until we reach again a line of application code. Now we can see that test shared was modified in an interrupt service routine that preempted the execution of the idle speed controller code while we were stepping through the execution of that code. We can now move forward again, disable the breakpoint, and resume the simulation. Thank you for your attention.